Dante Certification Level 2, 2nd Edition. IP address, subnet mask, and gateway. Towards the end of Level 1, we talked a bit about IP addresses and subnet masks. These are two of the most basic settings on any network device. This time around, we'll go into a bit more detail. And again, we'll use your familiar home network environment as the example. Each device on the network gets a unique IP address. When one device wants to contact another on the local network, we contact them by that IP address. Now this is very much like placing a local phone call, where we just pick up the phone and dial the number. Instead of dialing a phone number, we're dialing an IP address. And just like a phone call, we know who placed the call and who received the call. You'll see I placed an arrowhead indicating the laptop contacted this unit here. However, you'll notice I did not place an arrowhead at the network switch. Now that wasn't a mistake. The network switch is trying to be as transparent as possible, seamlessly linking your transmitter to your receiver. And again, you can think about your phone analogy. When you dialed the phone, you just dialed the number you wanted to contact and you were automatically connected. Behind the scenes, the phone company automatically connected you through switching stations. You didn't have to know any of that infrastructure, right? That was all automatically handled for you. On a local area network, that's exactly how it's going to work. Now this differs from how we reach devices outside your subnet. If we want to contact this server, we reach that by first contacting the router. So anything the operator hears in one handset, it will repeat into the other, and vice versa. Now this is a little bit different than the old phone analogy. Usually once the operator had the two lines, the operator would connect them and be off the call. But in this case, the router is an active participant in this connection. It continually translates between those two calls. Now, when we called the operator, we knew the operator's phone number. 0, right? 0 was the operator's phone number. In your network settings, the gateway is the IP address of the router on your local area network. And of course, the router will also have a connection on the wide area network side. It's linking the two networks together, and each port has its own IP address. So if we want to make a connection on the local area network, we can make that connection ourselves. However, if we want to contact a device outside of our local area network, perhaps on the wide area network, we contact the gateway, the router, which will then open up a second connection to complete the next leg of our journey. So this brings up a question. How does our network device know if the destination is found on the local area network or if it should contact the gateway? Well, it figures that out by using its own IP address and subnet mask. And many of you will probably know this intuitively. Let's suppose my computer on my home network has an address of 192.168.10.11. I think that many of us would intuitively assume that the subnet mask is 255.255.255.0, and devices on the local area network will have an address in the range of 192.168.10. something. Who knows where we learned this? We just know it is so, right? Well, let's go through and explain why this is true. When we describe IP addresses to each other, we usually describe it in dotted quad or dot decimal notation. Basically, this means your IP address will have 4 numeric fields separated by periods or dots. Notice your subnet mask is expressed the same way. And ultimately, we'll want a range of IP addresses that we can use on our local area network, and we will express that in the same way. So in the first field of our subnet mask, we find a 255. This tells our machine that any device on our local area network will match our IP address in this field. So we copy that down. We find values of 255 in the next two fields as well, so we copy them down also. Now in the last field, we find a 0. A 0 means we can have any number we want in this field, and the device will still be considered to be on our local area network. So that's pretty simple, but let's clean up our language a little bit. A lot of people call this my group of local IP addresses. The proper term is a subnet. So if the device is in your subnet, then the network device will contact that IP address directly. If the device is not in your subnet, then we contact the router, and the router will establish another link for the next leg of the journey. All right, so quick quiz. Let's suppose these are the settings on my computer. I'll throw out some IP addresses. You decide if these would be found on your local area network or if you're going to go to the gateway. The first is 192.168.10.18. Well, this is found on the local network, no doubt about it. Okay, how about 18.231.109.77? That is certainly on the wide area network, so we go to the gateway. But how about this one? 192.168.1.197. Now this one trips people up a lot because it looks like a local area network address, and you're not wrong about that. But the question is the device in our subnet? If we look at the screen, that third field should have a 10 in it if it's in our subnet. And it fails that test. The address we're evaluating has a 1 in that third field. So we would go to the gateway to find this device. Now, as we'll learn in level 3, it may not be going to the wide area network. It may go to another local area network, but for sure you're going to the gateway. No doubt about that. So let's look at this a couple different ways. Here are two examples where I change the IP address, but I keep the subnet mask the same. We see that can yield different subnets, right? Here's another example. In this case, I'm keeping the IP address the same, but I'm changing the subnet mask. What happens now is we change the size of our subnet. Now in this top example, I can change the last field of this IP address to any number I want, and the device will be considered to be in my subnet. Now there's some reserved numbers in there, but let's say that's just over 250 addresses available to me. In the bottom example, I can change 2 of the fields of the IP address to any number I want. That gives me over 65,000 IP addresses available to me. So, changing the subnet mask changes the size of my subnet. Okay, so that gives us an explanation of subnet masks like these that are commonly found in residential networks or in the Dante default network when we go link local. But occasionally, you'll bump into subnet masks like these. Now, what exactly do these other numbers mean, 248 and 252? To introduce this next part, I'll just put a little bit of geek humor in here. The way this actually reads is there are 2 types of people in the world, those who understand binary and those who don't. Because of course, 10 in binary has a value of 2. Now the reason I bring this up is because for the next few slides, we're not going to be looking at IP addresses in dotted quad form anymore. We're going to discuss it from a binary perspective. Now don't worry, you don't have to do any translation between binary, decimal, and back again. That's already done in the PowerPoint. All we want you to understand is the mechanics of how it works. And I think that will shed significant light on these other subnet mask values as well as the best practices around them. Now when we look at an IP address in dotted quad notation, of course we have 4 fields. Each has a range of 0 to 255. For anyone who works with MIDI, DMX, or graphics, 0 to 255 will sound familiar as an 8-bit range. So, if we think about this, the IP address is really a 32-bit number. The dotted quad notation just describes the IP address in a more memorable form for us. And in fact, the subnet mask is also a 32-bit numbers. The periods between the fields aren't used by the processor any more than your calculator interprets commas when we type in numbers in thousands, millions, and so on. Those commas are just there so people can relate to the numbers more readily. So when the subnet mask is applied, it doesn't work at a dotted quad level, it works at a binary level. A binary 1 in the subnet mask means we copy this bit down from the IP address to our subnet. Here we have another binary 1. We bring that down, and so on and so on. When we reach a binary 0, that means we can have any number we want in this field, and the IP address is deemed to be in our subnet. And of course, the reason why we start the explanation with just 255 and 0 is because it's very easy to explain that to people, right? It addresses the entire dotted quad field at a time. Now, if someone was to describe this IP configuration, they might just list their IP address and append a /24 at the end. The /24 indicates the subnet mask has a length of 24 binary 1s. There's 3 dotted quad fields, 8 bits each. Well, that's 24 bits. Now, the best practice is that the subnet mask should always be given as an unbroken string of binary 1s, followed by an unbroken string of binary 0s. So this subnet mask is bad. As we go across, we have binary 1s, then we start to have binary 0s, then we go back to binary 1s. Now this is a party foul right here. IT will make you do the walk of shame. Okay? The best practice is to have that string of binary 1s go to a string of binary 0s, and that's it. What happens here is you don't get a clean range of IP addresses that are valid. You'll get a checkerboard of things that are in and out of the range. We don't want that. Likewise, here's a subnet mask that breaks the string of binary 0s within the dotted quad field. Once again, let's not do that. So if we think about this for a moment, we'll realize that there are only certain values that are available for use in a subnet mask. 255 and 0 will continue our strings of 1s or 0s. These other 7 values will represent the break midfield. Now, if you're curious, and for the sake of completeness, let's show you a couple of subnet masks using these other values, and we'll show you how they play out. So here's an example where the third field of the subnet mask has 6 binary 1s. Those bits need to be carried down exactly. The last 2 bits can be whatever we like. So we can have values from 00 to 11. That gives us a range of 0 to 3 in decimal form. Now this is the part where it gets a little tricky. If I change my IP address, I can get a different result. Now, in this third field, I have some binary 1s that need to be copied down from the IP address, right? So now I can go from 11000 to 11011. And those have a decimal value of 24 to 27. So if that helps you, great. If not, hey, don't sweat it. You can just stick with subnet masks that are 16 or 24 bits long, and you know how those work just fine. So in summary, a subnet mask helps you define what is in your subnet. The subnet mask should be an unbroken string of binary 1s, followed by an unbroken string of binary 0s. For devices in your subnet, you'll contact them directly on your local area network. Devices outside your subnet, you'll be contacting the router, which will then open a separate connection for the next leg of your journey.